In this video, we will do the AC analysis of a common source amplifier circuit. Here, we will do the AC analysis taking two common source amplifier circuit. One common source amplifier circuit will have the bypass capacitor, another common source amplifier circuit which will not have any bypass capacitor. Now first we will do the AC analysis of a common source circuit which will has a bypass capacitor. To do the AC analysis, we have to short circuit all the DC sources to the ground, and then for AC, all the capacitors will be shorted, because for AC we know impedance Z equivalent to 1 by omega C, omega equals to 2 pi fc. With the increase of f, impedance decreases, so all the capacitors will be shorted. After shorting, the circuit will be look like that. As this source terminal is now directly connected to ground, so we can remove this source terminal. After we can remove this RS source resistance, so after removing this, it will look like this circuit. Now MOSFET, a dependent current source, we know this NMOS is can be represented with a dependent current source. So here we can remove this MOSFET and replace this MOSFET with a dependent current source and a parallel resistor RD. The value of RD is very high, so we can make a equivalent small signal equivalent circuit of this circuit. Here we remove this MOSFET and place a equivalent voltage dependent current source there, and now in this circuit you can see that this R1 and R2 are parallel, because one end of this R1 R2 is connected to gate and other end is connected to ground. So here two R1 R2 will become parallel to each other, and this drain terminal is connected to ground with a RD. So this RD will come across between the drain and ground terminal. This is the equivalent small signal circuit. Let's find out the input impedance. To find out the input impedance, we have to look through this terminal, and if we look through this terminal, you can see that gate is not connected to drain terminal, because the gate is separated by a dielectric material. So if we see through this terminal, you can see this R1 R2 are parallel to each other, so equivalent input impedance is R1 parallel R2. Now let's find out the output impedance. The small signal equivalent circuit is this. To find out the output impedance, we have to provide a potential at the output terminal, and all other potential supply will be shorted to ground. So if we short the gate terminal with the ground, then VGS will become 0. So as VGS is 0, so the current passing this through this terminal will become 0. That means this voltage dependent current source, this current will become 0. That means they will be open. So we can remove this, the voltage dependent current source here. After removing that, you can see that now this smaller RD and capital RD are parallel to each other. So if I want to find out the output impedance through this terminal, we can see that these two are parallel, so output impedance Z0 equals to smaller RD parallel to capital RD. As the smaller RD is very higher than capital RD, so output impedance will become equivalent to capital RD. Now let's find out the transconductance and gain of this circuit. To find out the transconductance, we know the transconductance is nothing but the change of output current with respect to change of input potential VGS, and when VDS is constant. So if we take the derivation, we can see that the transconductance Gm equals to mu Cox W by L into VGS minus VTS. VTS is the threshold voltage. Now this is the small signal equivalent circuit of this circuit. Now let's find out the gain of this circuit. To find out the gain is nothing but the output potential. Voltage gain is nothing but the output potential by input potential. Now here you can see that the current passing through this capital RD, if we write it as I capital RD, and current passing through this smaller RD is I smaller RD, then the total current is the summation of this branch current plus this branch current, and that is the total current is GMVGS. So we can say GMVGS equals to I smaller rd plus I capital RD. Now from this we can find out how much current is passing through this capital RD with respect to the total current GMVGS. The total current is GMVGS. So current passing through this capital RD is GMVGS into smaller RD by smaller RD plus capital RD. Now let's find out the voltage gain. Voltage gain AV equals to the output potential by input potential. Output potential V0 is the potential drop across this resistor capital RD. So potential drop across this capital RD is capital RD into I capital RD. As the current direction is opposite, so we can put a negative sign here. So V0 equals to minus I capital RD into capital RD by the input potential Vi, and input potential Vi is nothing but the potential difference between gate and source VGS. So gain equals to I capital RD into RD by GM by VGS. Now this IRD is replaced by GM VGS into smaller RD by smaller RD plus capital RD into capital RD by VGS. VGS now cancel out. So the gain AV equals to minus GM into smaller RD by smaller RD plus capital RD into capital RD. Now as this capital RD is very smaller than this smaller RD, so we can neglect that part, and the equivalent voltage gain will be more or less minus GM capital RD. Now let's do the AC analysis of a circuit which do not have bypass capacitor. Now this circuit do not have bypass capacitor, so we can make a equivalent circuit for AC analysis like that, DC is shorted to ground and all the capacitors are shorted. After that, we can make a small signal equivalent circuit looks like that. Here, the MOSFET is replaced with a voltage dependent current source as the smaller RD which is parallel to this voltage dependent current source is very high. So we have considered that the terminal is open. So we have not mentioned here the smaller RD. Now without bypass capacitor, this RS is connected between the source terminal and ground. So this RS is connected in small signal equivalent circuit between source terminal and the ground terminal. And this RD is connected between this drain terminal and ground. Also, these R1 R2 are parallel to each other as we have discussed earlier. So that has been referred here. Now the drain current is passing through RD. So this output potential V0 is nothing but the drain current into capital RD. As the drain current direction is opposite, so negative sign comes here. V0 equals to minus capital ID into capital RD. Now ID, this current totally flows through this voltage dependent current source and the value is GMVGS. So ID equals to GMVGS. So we can write V0 equals to minus GMVGS into capital RD. That is written here. Now this GMVGS current also flows through this RS. So potential drop across this RS is Vs equals to ID, the current ID into RS, and ID equals to GMVGS. So Vs equals to GMVGS RS. Now if we see the input potential is given between this terminal with respect to ground. So this V in is the total potential is divided between the gate source terminal and the potential drop across the RS. So Vi or V in equals to VGS plus Vs. Okay, so VGS plus Vs equals to GM VGS RS. So we have replaced here, and now we can write Vi equals to VGS into 1 plus GM RS. Now VGS equals to, we can write Vi by 1 plus GM RS. So we have find out the VGS with respect to input potential. Now let's do the output potential. We have find out that in equation number 1, V0 equals to minus Gm VGS RD. Now we replace the VGS from here with Vi by 1 plus Gm RS. Now if we do that, then from there we can find out the V0 by Vi, and that is the gain, output potential by input potential. So potential gain V0 by Vi equals to minus Gm RD, capital RD by 1 plus Gm RS. Now here you can see that the gain is reduced by this RS, capital RS. This RS source resistance which is present here. So without bypass capacitor, this RS will be present in small signal equivalent circuit, and that will give a reduction in the voltage gain. Now let's find out the input impedance. To find out the input impedance, let's look through this terminal, and if we look through this terminal, there we can see the R1 R2 is parallel to each other, so input impedance is equivalent to R1 R2. Now let's find out the output impedance. To find out the output impedance, let's put the output potential. Let's put a output potential at this output terminal, and other the supply will be shorted to ground. So this gate is shorted to ground. So after doing that, we can make a circuit like this, where this part, this potential drop between this gate terminal with respect to this ground, that is 0. So VGS plus the VS equals to 0. Now we know Vs equals to IDRS. So Vs equals to the GM RS. So VGS plus GM RS equals to 0. Now if we take the VGS common, then we will get this equation. From there we can write VGS equals to 0. So if VGS is the 0, then no current will pass through this branch. That means this branch is open. So after getting that, we can make this circuit look like that. And now if we see from this terminal, you can see that only one RD is present across the output terminal. So the output resistance or impedance is Z0 equals to capital RD. Okay, thank you.